Pyruvate dehydrogenase deficiency is a metabolic disorder characterized by the buildup of lactic acid, as well as a variety of neurologic problems. I'm going to give you a visual mnemonic to help you remember this disease so you'll be ready for test day. If you haven't already watched our scene on pyruvate metabolism, I would recommend starting with that one first, as it gives some contextual understanding about why this disease matters. Man overboard, mateys. That's three-headed Davy Bones in the water there. Looks like a pirate hydra if I've ever seen one. Remember how a pirate is our recurring symbol for pyruvate, and hydras are our recurring symbol for dehydrogenase enzymes? Well, it follows that this pirate hydra must therefore be our symbol for pyruvate dehydrogenase. And our pirate hydra has been thrown overboard, which should anchor you to the scene on pyruvate dehydrogenase deficiency. And you probably didn't know, but Davy Bones never learned how to swim. You would think that pirates would know how to swim, but this guy's the exception. Just look at him, holding onto his cross for dear life. I guess his fate is out of his hands now. By the way, this small cross should remind you of X-linked recessive inheritance. Get it? A small X-linked cross for X-linked recessive. Pyruvate dehydrogenase deficiency is inherited in an X-linked recessive pattern. In effect, this means that it primarily affects boys, and family histories will talk about uncles and grandfathers who had the disease. Just remember this small cross to peg X-linked recessive inheritance. Alright, so it's pretty obvious that pyruvate dehydrogenase is deficient in, well, pyruvate dehydrogenase deficiency. Let's briefly review the normal function of pyruvate dehydrogenase so we can understand why this deficiency causes problems. If you watched our scene on pyruvate metabolism, you would know that pyruvate dehydrogenase is responsible for converting pyruvate into acetyl-CoA, which is in turn used to make ATP via the citric acid cycle. Therefore, pyruvate dehydrogenase deficiency blocks the generation of ATP, resulting in energy deprivation. Tissues which require a lot of energy, like neurons for example, are especially affected. On the note of neurons, take a look at that frayed bundle of wires attached to the boat's motor. Oh, now it makes so much sense why our crew is stranded at sea. It seems like the power to their boat was cut. These frayed wires should remind you of neurologic defects. You know, since wires kind of remind me of nerves. The neurologic defects observed in pyruvate dehydrogenase deficiency are heterogeneous and can include motor delay, hypotonia, seizures, ataxia, as well as abnormal eye movements. But don't remember this laundry list. Instead, you should just remember why neurodegeneration occurs. It's because neurons are high-energy cells, and these neurons are deprived of energy in the context of pyruvate dehydrogenase deficiency. Now, being stranded at sea makes supplies valuable, and it looks like one of our pirates here was hogging all the supplies. What supplies? Well, we're talking about milk and aloe. Milk to drink, and aloe for sunburns, of course. What else could a pirate need at sea? However, notice how both the milk and aloe went flying into the air as the boat tipped. Serves him right for being so selfish. Anyway, this picture should remind you of the elevation of lactate and alanine observed in pyruvate dehydrogenase deficiency. You know, since milk is our symbol for lactate, and aloe is our symbol for alanine. Get it? To understand why lactate and alanine accumulate, think back to our scene on pyruvate metabolism. Specifically, the pyruvate normally used to make acetyl-CoA builds up, you know, since pyruvate dehydrogenase is deficient. This excess pyruvate is instead shunted down alternative pathways. Notably, excess pyruvate can be converted into lactate via lactate dehydrogenase, otherwise known as LDH, or into alanine via alanine transaminases. And there we have it, milk for lactate and aloe for alanine. Pretty easy, right? The buildup of lactate is especially important, since the combination of neurologic defects and lactic acidosis in a boy should immediately make you think of pyruvate dehydrogenase deficiency. Just remember our milk and aloe being thrown in the air by our boat tipping, and you'll remember these changes. So why was the boat tipping in the first place? Well, it's because of this pirate here. This somewhat larger pirate may have tipped the boat over, but it looks like he's now doing his best to save our pirate hydra. Recall how fatty acid breakdown enables fatty acids to be converted into acetyl-CoA, or ketone bodies for energy, in a process that's independent of pyruvate dehydrogenase. In short, since these patients can't use glucose for energy, they should consume fat instead. A ketogenic diet, if you will. Anyway, this pirate really has more of a conscience. He's trying to save Davy Bones by throwing this piece of lace, but weirdly, this lace has a lot of loops. The lace and loops remind me of two amino acids, lysine and leucine. You know, lace for lysine and loops for leucine, or loopsine. Lysine and leucine are ketogenic amino acids, and they should be increased in the diet as a treatment for pyruvate dehydrogenase deficiency. Just remember how this pirate is throwing a piece of lace with loops as handholds to remember this treatment. Alright, and that's all you have to know about pyruvate dehydrogenase deficiency. Let's recap. Pyruvate dehydrogenase deficiency is an X-linked recessive disorder that prevents pyruvate from being converted into acetyl-CoA. This in turn impairs the cell's abilities to use glucose to make ATP. Patients develop a variety of neurologic defects due to energy starvation in neurons, and blood tests will reveal increased lactate and alanine. Treatment involves a ketogenic diet with high fat and consumption of the ketogenic amino acids, lysine and leucine. And now we are actually done. Let's maybe help old Davy Bones out. See you in the next one.